This is a code walkthrough for the example file ClassObjectCounter.java. This is a very simple example, and it's a stripped down class, but it illustrates using a static variable to implement an object counter. So let's take a quick look at this class. We've got two private instance variables, one integer and one string, and then we've also got this static variable called count, and we initialize it to 0. And so the idea here is that every time we instantiate a new object of this class type, we're going to up this count and maintain a running count of all objects created. Remember that we said that static variables don't belong to any one object instance, but instead to the entire class. So every object that's created is going to have access to this one static count variable, and we can keep track of how many objects have been created. So as usual, we've got a couple different constructors. Here's a default constructor, here's a full constructor, and here's an intermediate constructor with only one input argument. But notice that in each case, when we instantiate an object using one of the constructors, we also increment this count. And we actually do the same thing for this constructor as well, except we do it indirectly. By calling this method here, we're calling the default constructor and taking advantage of the count increment here. In other words, we're not incrementing it an additional time at this point. Now if we scroll down a little bit and take a look at the rest of this file, we'll see that it's kind of stripped down. We don't have all the usual accessors and mutators and equals method and display methods and so forth, but we do have one display method for objects to print themselves, and we do have this getCount accessor. This is how we get to the static count variable, and notice that it is itself a static method, so it's called using the name of the class. The reason we do it this way is because this count variable is initialized when this class is brought into memory by the Java virtual machine. So there's a count of 0 before any objects are even instantiated. So there's a legitimate count that we might need to obtain. If we do it independent of any objects existing, by definition it has to be a static method. Now down here we've also appended some main test code to test this class, and we can imagine this as being some sort of client application in another file, but for now this code will be simply co-located in the same file as the class. So let's, as always, let's compile this, and we'll set a breakpoint on main and step our way through this, and it's going to jump back and forth in this class as it executes. So we'll start executing this with the debugger, and right now, before we've created any classes, we're going to print out the count of objects. So again, we're calling this statically using the name of the class, the static method getCount, and when we execute this, we see that we've got 0 objects created so far. So then when we create a new object using the default constructor, we'll step into that, and we go through the constructor. We're initializing the two instance variables, but we're also incrementing this count, and once we return to where we were calling it in the client, we'll print out our object and we'll print out the count, and now the number of objects is incremented to 1. So we'll do the same thing here with a full constructor. We'll create a new object, and notice that as soon as we did that, our count went up to 2. And notice that these are our two individual object instances, but this count is apart from and distinct from any of these objects. But it's been incremented to 2. We print out our object and we'll print out a count, and we see that it's 2. So we'll do the same thing here, and I'm going to step into this one, and now we are in that third constructor, and notice that the call to this is going to step to the default constructor to initialize these variables. At this point, the count will be incremented, and we see that here. And now we come back and set the variable for the one instance variable and go back to the flow of execution in our client, and we will print our object out and for the last time print the count, and we see that it's correctly set to 3. And we'll finish up. What we don't want to do is the following. For example, let's say that we mistakenly put this statement in here and tried to up the count inside each of these constructors. Look what happens now. I'll recompile the changes and we'll go back to our main program and step our way through. Again, we've got 0 objects now. We've created 1 object. With our full constructor, we've created a second object. But notice what's going to happen now. When we try to print out the number of objects, now it incorrectly reads to 4. And that's because when we add an increment of count here, we're double incrementing because we're already incrementing inside our default constructor. So we're getting it once here and once here. So this isn't what we want to do in this instance. But anyway, this is how we would implement a static variable used as a counter, and this main application shows how we can get to that count using a static method of the class.